Sorry. What's going on, my peeps and my 8th graders or 9th graders? Oops, sorry, I had you as 8th graders once before. I know you guys are big kids now. Don't let me do that to you. Say, dude, Mr. Dalday, don't play me like that. I'm a 9th grader now. I'm a high schooler, like straight up high schooler, all right? So I'm a big kid now. Exactly. That's right, buddy. That's right. Stand up for yourself. Anyway, can you guys hear me all right? Say good morning. Good. No one wants to wish me good morning. Oh, there we go.
Bad morning.
Oh, wait. I get it. I think that what's going on is, for some reason, I'm only getting some of. Oh, I guess I'm getting everything. I don't know. All right. Anyway, if you're gonna chat it to me on the everyone side. Don't just chat it to me personally, because it just kind of gets a little confusing then. But how's it going with you? I'm sorry for stealing you away from your English class. I know that you guys were just going, but then again, you weren't in your English class, were you?
No.
Yeah, well. But I'm sorry for stealing most of you away from your English class. So, you know, she said, come on over if you can. What's going on?
It was a terrible morning.
Okay.
Freezing.
Oh, it's cold. It's a cold, terrible morning. Yeah, you look like you're from Chicago with, your beanie and your gloves and whatever. It's not even your gloves, but your long sleeves or whatever. All right, here's my deal is I'm going to try to stop telling stories, which is tough for me because I like telling stories because I think they're funny. And what I'm going to do is I'm going to try to get through all of our material in like an hour. And then we'll just be done. Half hour, leave half an hour early. Sound good? And I got my hoodie up. And I was walking to the bus. So, I don't know.
The bus driver had the air conditioning on when we were on the bus.
I know. Why do they do that? That's so dumb. All right. Anyway, let's get this party started. So we finished. All right. I think as far as homework goes, this is pretty much what's due. Up to here. Like up to quadratics 1. All of this homework has been due. I think this one is due like today. Okay? As far as lectures go, we're going to start quadratics 2, or quadratics 3. I already finished all of quadratics 2 lectures. Does that make sense? So, we are a week ahead of where we're supposed to be. Actually, we're almost a week and a half, or even 2 weeks ahead of where we're supposed to be, because I'm not where we're supposed to be, but I'm lecturing ahead of time, and then I give you a full week to finish it. So, you add that to the week ahead that we're at, and we're doing kind of well. And this is the pace I want to keep it at. I'm not saying we're a week and a half ahead because we're going at a super fast pace. What I'm trying to do is remember how I said, okay, we're going to cover the first quadratics 1. We're going to take 2 weeks to do it instead of just the prescribed 1 week. Well, in that 2 weeks, I got through that quicker than I thought I would, and I want to stay ahead. Because the thing is, I hate it when teachers assign homework, and it's homework on things that they haven't even talked about yet. You know what I mean? Have you guys experienced that?
Mm-hmm.
We're like I don't know how to do this homework, that the teacher didn't even lecture on this. So my goal is I'm trying to be like, all right, well, I lectured on it last week. So start doing your homework now, okay? I don't want to get too far ahead, but then again, I don't even want to get it to be where it's the same, where you're assigning homework and the day it's due, I finish lecturing on it. That's stupid. All right? I should be finished lecturing on it a week before it's due. So that's kind of where we're at. So we're going to start up on lecture 3. I think it's going to be a quick one, which is why I'm spending the time talking about it. But anyway, pull up your quadratics number 3, and we're going to go through it. The stuff circled in blue is... Okay, wait, I've got another call coming in. Hold on, let me take this call real quick. Hold on. Hello?
Hi, Mr. Dalday. I know you're in the middle of the WebEx. It's Ginger.
Hi, Ginger.
Hi. They got new Surface pads.
Yeah.
And they're not able to log on. So, and then one of their Myron B laptops is at Myron B.
Uh-huh.
So they're logging on tandems, I think, right now, both of them.
Got it. I'll expect them I'll expect them when they can get in. And then I'm archiving all of this.
What?
I'm recording all of this so that they can watch the archive later.
Okay, but they're gonna hop on right now on
Sounds
the one
good.
laptop. The both of them though.
All right, cool.
Okay, thank you.
Goodbye. I'm sorry, folks. I had a parent calling in saying, we'll be there. And I'm like, okay, we're good. So we're going to inspect the young twins coming in just a second. All right, the stuff I circled in blue is from your homework. Like, this is what you need to do as homework. So should I do it for you in class? Yeah, that would be really cool. But,
You circled one thing. Does that mean that's the only homework assignment?
no, I circled a bunch of stuff throughout here. There's a lot of, I mean, it's not even a lot of homework. But I'll tell you what. I'll probably do similar problems, very similar problems. In fact, I'll just change the numbers a little bit, and then basically your kind of homework is pretty much done for you. You just got to go through and plug in the numbers yourself, the correct ones, that is. Sound good? So I'm going to try to stay away from doing your homework. If I accidentally do something that is your homework, then hey, why don't you write it down? And hey, why don't that be a great lesson to learn about? Like, wait, I should attend class because he does my homework for me. Sound good, right? All right, cool. And just to let you know, I actually save all of these notes in a Google Drive file that you guys can get to. I don't know if you guys knew that.
No. Why would we ever know that?
Because it says right here,
But that means our homework's basically
Teacher
done. We already know
Active
that.
Notes. Click to download the notes I took in lecture. If you click on that...
I bet you none of us ever clicked that.
Alright, fine. I'm showing it to you now. If you click on that, it will give you a file. It will give you a folder.
Or watch the archive.
Yeah, or you could watch the archive, but, you know, like, I noticed Diamond was like, Mr. Dalton, can you go back a few steps? Because I didn't have time to write everything down. You know what I mean? What I do is after every single time I finish a lecture, I save the file into this Google Drive right here. And you can see, like, okay, these are my notes. This is what I wrote down on the board in 2014-01-10, January 10th. This is from January 15th, January 17th, January 22nd. Apparently I didn't write down my January 24th notes. So you pretty much have everything that I have. You have all the notes that I have. So you don't even necessarily need to like frantically write everything down from here. You can just download it once you're done. We cool? So I'm just letting you know this for like people like Brandy who didn't print out the stuff. And Brandy's like sitting here just like, well, I'm just going to watch. I'm going to learn. I'm just going to watch and learn. That's what I'm going to do today while Mr. Dollardy's lecturing. I'm not going to write down every single thing that he writes down because there's no point. Because I can just download that later. You know what I mean? No, it's not that we're just lazy like that. It's just I'm trying to provide you guys with
I'm
another
lazy
resource.
like that.
No. What I'm saying is like some people learn by just like I learn by writing everything down. So whenever I'm sitting with a teacher and they're teaching me something, I'll write everything down. And then I'll write my own notes in there. That's the way I learn. Some people feel that like writing everything down is necessary, but they'd rather just kind of just sit and watch and just go like, I understand. That's pretty good. Yeah, word to your mother, you know? and then like, that's cool. That's cool because if you need all the stuff that's written down, you can just download those paint files that I have uploaded there. So anyway, that's kind of a nice note for Diamond and whatever. And now you guys know. It's in your class. I have a link and it says click here to download the teacher's lecture notes. It's right underneath the introductory videos at the top of our class. Not the very top, because at the very top there's the plan. Cool?
Yes.
Alright, real fast question. I know I've wasted like 12 minutes already just talking story with you guys.
Yeah.
But I'm just want to make sure.
Best.
The class format, is that alright with you guys? Is the plan working out for you? Do I have all the drop boxes up? Do I have all the activity? You know what I mean? Is it clear?
Yeah.
Yeah? We're good? Any complaints? Any like things, Mr. Daldy, could you change this?
No, we're pretty good.
Alright, pretty good? Okay, good, fine. I'm cool with that. Let's we're good then.
I like how you have the plan all in one giant document, and when you click the link, it'll jump to that week. Because other teachers have the plan, and you click it, and then it brings up so many different things, and I'm like, no.
Oh, well actually I just added that feature for just this class.
That's wonderful.
So anyway, I think that you guys rocked graphing quadratics. In fact, I quite enjoyed graphing quadratics, and all we talked about was like, okay, if there's a negative number in front of the x squared, what happens to that quadratic? What happens to that parabola? If I have something like, let's review. If I have f of a, or f, there. If I have f of x is equal to ax squared plus c, if a is a positive number, or no, if a is a negative number, what happens to that parabola? It goes from pointing up to what? Word. From here to here, right? It points down. I guess maybe instead of a point down, it's like it opens down.
Yeah, because technically the point is
Right.
point.
Technically, I guess it points up then, really,
Yeah.
right? So I mean, it opens up downward. It's an upside down parabola, right? All right. Now, if I mess with this number, c, right? What does that do? If c is like 5, what does that do to the parabola? So I have like x squared plus 5. You guys remember? This is a warm up. It moves it up and down exactly. And if it's positive 5, then what does it do exactly? It goes up. Yes, very good. I love it. And if it's negative 5, then it goes down. Perfect. Exactly. And then we also talked about messing with that number. If that number is like a number that's bigger than the number 1, like 2 or 3, what does that do?
It makes it thinner.
It makes it thinner. It's a slim fast plan, right?
Yes.
And then if this number is not just smaller than 1, but if this number is a fraction that is smaller than 1, but it's bigger than negative 1, it has to be, you know what I mean, within this range.
It's bigger.
Then that's the cheeseburger plan, right? That's the one where like the thing got fat,
I dig that plan.
right? So we got the slim fast plan, which is when it gets skinnier, and we got the cheeseburger plan or the Big Mac plan, and that's where you get fat. Sorry, people who eat Big Macs. I wouldn't recommend eating Big Macs all the time.
I do all the time. Oops.
Big Macs are good. I mean, I like Big Macs, although Whopper or Big Mac, which one's better?
Big Mac.
Really?
I'm not a fan of Burger King.
I like the Whopper
We all know that Jack in the Box has the best burgers anyway.
for the taste, but I don't really like anything else from Burger King.
Same.
Like, I'm not like, Burger King rocks with all its other food. It kind of sucks.
Besides, we all dig
But the
Jack in the
Whopper's
Box
better,
burgers
I
more.
think.
Jack in the Box has better burgers in general.
I
over
like
life.
Carl's Jr.'s burgers.
Never had Carl's Jr.'s.
You know what? You know what my favorite burger is, though?
Wendy's is pretty good, yeah.
All right, so if we're talking off island, we're talking about like In-N-Out. That is a good burger.
Never had it.
Oh, that's when you go over to like the big, or to like what I mean by the Big Island, I mean like California. Yeah, In-N-Out is sick, crazy good. If we're talking about like a place that's in Hawaii, Teddy's is good. It's
I
too
actually was not
too
impressed with
expensive.
Teddy's like at all. The
The,
only thing I liked was their malts and their milkshakes.
the things that is like super killer. What's going on, Breland?
I have limits. Yeah, you
Yeah,
don't
I'm in
have
my
a
class.
class.
Why?
Because I want you to help me with my math homework.
Wait. What? You're asking me for help?
Yeah,
Because-
Bree's asking for.
All right. I'll see when I can help you. I'm pretty much booked for the day, but I'll see what I can do. Got it? All right.
Try to find
What
out.
math are we talking about?
Trigonometry.
All right, we're talking about trig tutoring. Someone came and wants trig tutoring. This person who hated me as a physics teacher. She just hated it. And you know why she hated me as a physics teacher? Because of trigonometry. Ain't that the truth?
Oh, yeah.
Yeah, all right, fine. Let's move on. You know what? We totally spent like 5 minutes talking about burgers. But I'm just letting you know that this place called Shige's in Wahiwa, it's kind of a hole in the wall, has the best burgers. Hands down.
Or In-N-Out.
All right.
We already
We talked about In-N-Out. In-N-Out is good, but that's not on the island. Anyway, Shige's, it's hole in the wall. Anyway, we talked about that. But let's move on to finishing this off this lecture, because I promised you I would finish off a half hour early, and the more stories I tell, the more I won't be able to make that promise or keep that promise. But let's talk about this one. If I had this as a graph, and it looked like that form ax squared plus c, what would you say a is? Is a positive number? Is it a negative number? Is it a like -2? Is it a +2? Is it a +5? What is it? What do you think? John says, which I'm thinking is negative. Negative. John says negative. Diamond says -2. You know, to be honest with you, I agree that it's negative. I can't tell whether or not it's -1 or -2. I just know that it's going down. Actually, there are units on that, and it looks like it does cross at -1, -1. So, yes, I agree with you. It is negative. All right, what about C? What is the value for C? Is it positive? Is it negative? Or is it 0?
0.
And why is it 0?
It's because it's
Because it didn't move up or down. It's just kind of right there. So we know that A was negative, and we know that C was 0. Is this hard to do or what? Like, this is good, right?
What just happened in the chat box?
I don't know. I don't know who did that. I can't even. Oh, Ted. Thanks, Ted. I appreciate it. That's a big
I think
hyperlink.
it's a link.
Oh yeah, it is a link. Totally a link. I'm gonna go check out that link later and watch. It's gonna be like, the link is gonna be like, this is the shortest document in the world. The end, right? But then like the hyperlink is way longer than it. Anyway, let's move on. Let's talk about this guy. Tell me, look at
I
this.
think it's bacon.
Look at this parabola, and tell me, is A positive or negative? It's negative. Awesome, because it's opening downwards. Is C positive or negative? Brandy says negative. C, I'm talking about C. I don't necessarily know what the equation of this graph is, but I'm wondering is it going to be a negative or positive? And why do you say negative?
Because it's starting down there.
Because it's moved down. Originally it started here, but then you moved it down.
Yeah.
How far did you move it down?
It looks like.
If this is -1, -1/2. I totally agree. So I would argue that the form of this, without even really knowing what the symbolic equation of this parabola is, I would say that it's -x² -1/2. Would you guys agree? That the -x² tells me open the thing downwards. The -1/2 tells me to push this whole thing down 1/2. We cool? So this is a negative and that's a negative, and that's really what your warm-up is. And just think, number 4 is your homework. If the warm-up was that easy, then the 4 is the homework. I can't believe this. I love homework in this class. It's awesome. Anyway, let's move on. 2x², what does that do to my graph, my friends?
Put the thingy upwards.
All right, so what do you mean the tip of the thingy upwards to?
It goes up 2 bucks. Thingies where the.
All right, so here's a regular parabola, right? This is a regular parabola. What does the 2x² do?
It moves it up to.
It makes it skinny.
What?
Makes it skinny. It doesn't move it up to. It makes it skinny.
That's not C. That's X.
Right, this is the A. This is the thing in front. It makes it skinny. Yes, we are on the slim fast man. So it makes it skinnier, kind of like that. Do you guys agree?
Yes.
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 Or if you want to make it, if you want to say it makes it taller, I guess you could think of the parabola and just stretching it, making it
It
taller.
wouldn't make it taller because the 2 ends go on forever. I think so.
That's true. That's true.
Honesty, they're the same
That's
height.
true. I agree. It's skinnier kind of makes more sense because the tallerness of it is really just like, well, if parabolas go on forever, then essentially it's the same height. But then again, parabolas also go out forever, so it doesn't really make it skinnier either. Think about that. Put that in your banana and eat it. I didn't want to say put that in your pipe and smoke it. I just thought that was inappropriate. So.
You said it anyway.
But I didn't want. I'm telling you to because I didn't want to say it. Anyway, let's move on. -x² + 1. Let's graph that. Yeah, Mr. Dalda's gotten weirder over the years, I think. All right, what do I graph? How do I do this? Tell me. Walk me through this process.
Open downward.
All right, so we got a regular parabola, but this is not a regular parabola. It's opening.
It's gonna open downward.
You gotta flip it, and then what?
And then go down and go up 1.
And then go up 1. So it's flipped and up 1, and I don't mean that in the derogatory term of calling it a Filipino. Yes. I'm telling you I don't mean it that way. Yes, I flip it and I go up 1. Exactly. By the way, I am a Filipino. And I'm also Chinese. Which, yeah, I mean, works out well for me. All right. Tell me this. Look at this parabola right over here. Got it?
I was about to be racist.
No, just look at the parabola.
Yes.
Got it?
Yes.
All right. Tell me whether or not these could be the correct symbolic equation for that parabola. All right. 1/4 x squared. Can that be the correct one? I didn't put units. I didn't put little tick marks. I'm just letting you know. I have my reasons for that, but could that be the correct equation?
Be correct or incorrect?
Is it yes or no? Could that be a candidate for correct or?
It could be, considering you didn't put the hash marks, so we don't know how distanced they are.
Okay, all right. So the 1/4 does what to the parabola again?
Crap! It keeps doing that.
What?
Makes it wider.
It makes it wider. It's a cheeseburger plan, right? And this could be wider. I can't tell because I can't compare it to another regular parabola. There's no graphs. But I disagree with you in saying that no, this is not a symbolic equation for that because there we go, Kimilani. Because there is no c. This graph has to have been moved up or down. Actually, I know exactly how it's moved. It's moved down, right?
But there's no
So there is no
Okay.
C, so therefore no, my friends. All right, let's take a look at D. John's
Why'd you
suggesting.
skip B and C?
Well, no, because John's suggesting D.
Okay.
All right, so I'm just saying. All right, so D. Yes, I agree. There's a -5 there. It was moved down. However, is it the parabola that we're looking for? These are not the parabolas you were looking for. Now, I just wanted a yes or no on D. Is it no? Yes or no on D? There we go. Never mind, there's a -a. And a -a would have opened that parabola downwards, so therefore no, because of that -2x. Coolios? Alright, let's go with C. Let's go back and let's work our way back up now. I know you guys know the answer, but just give me a second, guys. Alright, fine. I'll go through it quickly. 3x squared. That's a parabola opening up. We're good. But, and this thing right here, I can't tell whether or not that parabola shifted, shrunk or wider. So I mean, really, 3x squared is just as good as 1/4 x squared.
It's not
However,
positive
the plus 5 over here means that parabola would have moved up 5. So therefore, no on this, but yes on B. Are we cool?
Yes.
So what I want you to do in your homework, which is, I did problem number 8, you do problem number 9, is basically. Tell me which one it is and why you think that. Like, I went through the explanation with you. You folks tell me, okay, it can't be this, it can't be this, it has to be this one because of this, because of all, here's my reasoning, here's my logic, blah, 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 blah. Are we cool? Good. Awesome. This is your student homework. It's like 6 problems long. Oh, it's the investigation, which is actually, you know what? I'm going to do you a solid and I'm going to do this. I'm not going to do your homework for you. But what I will do is do very, very, very similar problems. All right? I'm going to do it in red. So don't write over here in my lecture. Don't write over here in my lecture. Got it? Because that's where you actually do. This is your homework. But what I'm going to do is, instead of doing this problem, I'm going to do this. F of x equals x minus 3 squared. I'm going to do that. Cool? I'm going to make a table. This is x. Here's -2, -1, 0, 1, 2, 3, 4. All right. Let me show you what's going on. This is not the one that's due today. This is actually due in like 2 weeks. I know, isn't it cool? Like, I'm lecturing something, and then you can start working on it, and then 2 weeks later you finish. I mean, you don't even. It doesn't even take you 2 weeks. Like, seriously, this was This is what I expect you to do in 1 day. It's like 3 problems. I'm giving it to you now, and it's going to be 2 weeks, and it doesn't take 2 weeks. It takes like a couple minutes. So I mean, like, seriously, yo, do your homework, and you know what? Stop turning it in late. In fact, while I'm here, stop coming to class late.
But.
Because
I'm
I mean,
sorry.
like, I'm not that. My breath isn't that stinky. I mean, I brush my teeth. I take care of my hygiene. I'm pretty cool to hang out with.
I was like 3 minutes late.
I know. I'm not talking about you. I'm talking about and in fact, you know what's funny is I'm not talking about like the people that I'm talking to. I'm talking about the people who aren't here and watching the archive and just be like, dude, you better just show up for class. I know you have other WebExes like English. So I mean, never mind. It's called preaching to the choir. I don't know if you understand that term. Anyway,
Yes.
let's graph this thing by making a table, just like what we did for quad 2. We're going to do this for quadratics 3. All right. If I plug in -3 into here, -3 squared is, rhymes with dime. 9, there we go. -2 squared is,
4.
there we go. -1 squared is,
1.
I love that joke. It reminds me of my friend. His name is Juan. All right, 1. By the way, this is 9, and that's a 4, and that's a 1. 0 squared is 0, 1, 4, 9, and we graph that, and that's pretty easy to graph. You guys know how to do it. At -3, I go up here. At -2, I go up to 4. At -1, I go to 1, 0, 1, boom. Oh, wait. I messed up the graph a little bit. We're counting by 2s, apparently. There. So this is the graph of my regular parabola. Everyone agree?
Yes. Sure. Go. Yes.
Is this the real homework? Yes. This problem is your real homework. However, I'm not doing your homework for you in class. I'm doing this problem, which looks a lot like your real homework.
Mr. Walden, you always do our homework.
I don't always do your homework. All right.
You often do our homework.
Let's do this one in blue. Cool? All right, now I got a question for you. Here's a prediction. What we're going to do, all right, what we did before was we said, okay, let's compare x squared and x squared minus 1. Okay? And what did that do? What did that do? This was from last lesson. Oh, come on, you know this.
Do I?
Yeah. What does -1 do? It moved it down 1 in the y-axis.
Bullshit.
Okay, all right. Now what I'm going to do now is I'm saying,
I didn't know that.
let's compare x squared and x minus 1, or in this case, x minus 3 squared. What do you think that's going to do? If I have it outside of the x squared, it moves it up and down. Now what I'm doing is I'm putting that -1 or -3 or what have you inside of the square. Diamond thinks it's going to still move it up and down, but this time it's going to move it 9. There's other thoughts on that. Do you guys have, if this is how to move it up and down, but when I put it inside, now what do you guys think?
Thank you, Ted. I don't, maybe, I guess.
Sideways.
Right?
It might move it sideways. Are we cool? And, yeah, I know, I wasn't dancing. All right, it's going to move it sideways. All right, cool. Now, a -3, what do you think that will move it? Will it move it to the left 3, or will it move it to the right 3?
To the left. To the left.
Yeah, you just seriously quoted a Beyonce song.
Wait. To
Yeah.
the left? Is that Beyonce?
Yeah.
Swear to
Yeah.
God, I thought it was.
No, Beyonce was to the
Confused for a
right.
second.
She went to the right. It was George Clooney who went to the left. I know things. Anyway, yes. Thomas is saying. Wait, when you so we're predicting something. Hey.
Alright.
Nothing about sweaters in my math class. So we're predicting something when we put stuff inside of the parentheses, inside of the x squared term. That will move it right or left. And Thomas is saying, if it's negative, it's going to move it to the left, and if it's positive, it's going to move it to the right. We cool?
Yes.
Let's check that. All right. What I'm going to do is I'm going to plug in a -2 into here, and then square that. So what this becomes is -2 plugged into here would be -5, and you square that, and that would be 25.
Thomas is
Thomas, make sure that you watch the archive because I'm just going to go out to prove you wrong. I'm just letting you know.
Don't prove it wrong.
Well,
It's
I'm not trying to. He made a suggestion. It was wrong, but that's fine. I love your suggestion. All right, I'm just letting you know. So watch the archive. All right. Did you guys see what I did? I plugged in -2 into here. -2 minus 3 is -5. Square that, and that's 25. Yes? No? You understand where I got that number from?
Yes.
All right, good. I'm plugging -1 into here, and so that would be -4. -4 squared is 16.
Yes.
16. There we go.
Were you waiting for a student to answer that?
All right.
Or were you going to answer that? And you just paused.
Yeah, I just paused.
Because I would have answered.
All right,
if you
fine.
asked for a student.
All right. If I plug in 0 into here, what would I get out? I'll just ask that. If I plug in 0 into that x, what would f of x be? And Ted's saying it's -3, but I need to square that. So square -3, and that becomes 9. Positive 9. Are we cool?
Yes.
Okay. All right.
Very cool.
Now I'm going to plug 1 into here for the x, and that's 1 minus 3,
Which is -2.
-2, and then square it,
It's 4.
positive 4. All right, now I'm going to plug positive 2 in there. So that would be 2 minus 3, which is
-1.
1. No, 2 minus, oh yeah, -1. You're right.
Yeah, I'm right.
Yes, you're right. Okay, fine. You're right. All right, back off. It's -1
Squared.
squared is
1.
positive 1. Good. I'm going to plug in 3 into there. 3 minus 3 is 0. Squared is 0. Good. And 4 minus 3 is 1. Square that, and that's still 1. Let's graph this. At -2, you're going to go up to 25, so something way up here. I don't even know how to graph that. At -1, you're at 16, so still way up there. All right? We're outside of the range of our graph. At 0, I go up to 9. At 1, I go up to 4.
Yeah.
At 2, I go up to 1. At 3, I go to 0. And at 4, I go to 1. So my parabola looks kind of like this. Do you disagree? Or, I mean, do you agree? Yes or no? I know, it's a weird question to ask. Do you agree? Yes, I agree with you. So, look. When I added the -3 inside of the parentheses, it did move it right or left. However,
Why did it move it right instead of left?
it just did.
I got it. I feel you.
I'm just letting you know. I mean, this is our observation. I thought it would move left. To be honest with you, I actually thought it would move left as well. When I first learned this, I thought, putting that thing inside of the parentheses would move it left because it's a negative number. You figured negative numbers go left. But instead, it moves it to the right. Okay, all right, fine. I'm not going to argue with that. I'm just going to say, okay, cool. I'm cool with that. So that's kind of an interesting thing. So if I plug in a number into here, it does kind of the opposite of what I expected to when we're talking about right and left.
I don't feel like the Cupid shuffle
That's right.
now, Ted.
Walk it by yourself. All right. Anyway.
Did you know the Cupid Shuffle guy, the guy who created and sang the song, went on The Voice and sang the song as his audition?
What?
And he said it's because he wanted to venture out and not be known as the Cupid Shuffle guy, but he decided to use it as his audition.
I have a question. Why is the Cupid Shuffle always played on a Christian radio station? Because I listen
Is
to
it on the
Fish.
Christian?
And how is it like having to know about Christian
I don't
radio?
know. I just know that it's at every single middle school dance.
I'm just curious. I don't know.
Ever.
All right. Anyway,
Oh God, they're at high school dances too. Ugh.
wait. You guys focus. You guys want me to finish in 10 minutes, 20 minutes? Let me finish. All right. All right. So I'm not going to do this problem right here. That's your homework. However, what I will do is I'll do f of x equals x plus 2. Let's do that. What do you think will happen? I'm just curious. If I were to graph that, what do you think will happen? It will go to the left, not once.
But twice.
So it's going to go to the left, to the left. Okay, good. I'm just
No, they're to the left though.
just want to make sure if you know that. All right. It's going to move to the left twice. That's what our prediction is. Let's see if we're right. Let's make a little table. We got f. We got x. All right. We got negative. Let's graph -4. If I plug in -4 into x over here, I've got -4 plus 2, which is -2. Square that, and that's +4. So I'll graph that right now. Like that. Booyah. All right. If I plug in -3, that would be...
-1. Squared is 1.
Whoa. Okay, fine. -3 is 1. We happy?
Yes.
If I plug in -2, I plug
Zero.
-2 in, and it becomes -2 plus 2, which is 0, and then square that sucker, and that becomes 0. All right. So we got a 0 at -2. Let's plug in -1 into there. See what happens.
-1 plus 2 is 1. Squared is 1.
That is the weirdest.
That's my favorite voice to make.
You're
ever.
a weird person. All right.
Thank you!
Let's plug in 0. Let's see what happens. If I plug in 0.
0 plus 2 is 2. Squared is 4.
All right, fine. There we go. Let's plug in 1. 1 plus 2 is 3. 3 squared, 9. Graph that right there. This is my parabola. Compare that to what a regular parabola looks like, which is the dotted line. And what do you notice?
It's like the exact same thing, just moved over to.
Exactly. So, what we covered last week or what we covered the first half of this week and the end of last week, was we covered how to move a parabola up and down, and we covered how to make it skinny and fat, and how to open it up and down. This week, today, what we're covering is how to move it right and left. Now, the thing about moving it right and left is it's actually a little funny. Like, it doesn't, when we expect it, the x plus 2, you expect it to move to the right 2.
Yes.
But instead, it moved it to the
This is
left 2.
defying everything I ever learned about
No.
negatives and positives.
Oh, come on. This is just one rule that it's weird. I know, but I mean, deal with it. So that's all I'm saying. It's like, all right, let's see.
What time are you going to class? What time are you going to class? Probably going to take refuge in there soon.
So you got to finish this investigation.
So it's going to be something quotes on cough drops.
All right, I'll tell you what. Why don't we do this? I'll do one of your homework problems for you. Yes. All right. We're going to do page 8, number 2, the second part of it. I'll do it with you. We're going to do that one together. All right. If I were looking at this graph, -2, x plus 1 squared, x plus 1 parentheses squared. So the -2, or that's not -2, that's -1/2. The -1/2 is on the outside. The x plus 1 is on the inside. What is the -1/2 going to do? What is this going to do to it? It's going to flip it,
Flip it.
and it's going to make it more skinny. No, it's not going to make it more skinny.
Just going to flip it.
No, it's not going to just flip it. We're talking Big Macs here.
Speak. Oh, it's going to make it wider.
It's going to make it fatter because it's 1/2. Right? Right? You guys agree with me? All right.
Yes.
Now the plus 1, this plus 1 in here, what do you think that's going to do?
What?
See that plus 1 inside of the x plus 1?
Are you gonna
What is that going to do?
move to the left? 1.
It's going to move to the left, and that's it.
That's it.
All right. So I'm going to do it in orange. My guess is it's going to look like this, But it's not going to be a regular parabola. A regular parabola would look
Ted,
like this.
Stop copy and pasting that every time we say to the left.
Well, I think it's funny. Anyway, that's what a regular parabola would look like. I think that my prediction is it's going to be wider than that. It's going to look something like this. Something wider. That's our prediction. I didn't even finish. Well, I mean, it's all relative. It depends on how you really set your axis. But yeah, I think it's going to look something like that. All right, let's try graphing this and see exactly how it works. So if I plug in -2 into here, that would be -2 plus 1, which is -1. Square that is +1, and then multiply that by -1/2, and you get -1/2.
Multiply by half.
All right, well, you're just dividing by 2. It's not going to kill you.
Wait, what?
If I plug in -2 into here, you told me that -2
Yeah.
plus 1 is 1.
I know, but when I said
You square
multiply
that.
by half, you said that's the same thing as dividing it by 2.
Because that's like 1/1.
Multiplying by half is the same thing as dividing by 2. Yeah.
Yeah, see, I never knew that. I usually just Googled the number, multiply it by half, and then Google will answer it for me. It's like a calculator, but Google.
Yeah.
It's a calculator.
But you.
Yeah.
Yeah,
All right.
I know.
Anyway,
calculator.
I don't know how that's. Yeah. Well, anyway, hey, mind blown.
I literally just
Multiplying by half is the same as dividing by 2. Let me finish. Talk to the hand, all right? Because I'm trying to finish my lecture. All right. If I can finish this a half an hour early, I can help you with your trigonometry.
Finish up. Go.
If you keep interrupting me, I'm going to continue on, and I have a class at 11 o'clock, which I can't teach you trigonometry then. So let me finish. All right. And I'm not meaning that in a disrespectful way. You know I got nothing but love for you. All right, anyway. If I plug in a -1 into the x over here, -1 plus 1 is 0. 0 squared is still 0. Multiply that by a half, and you still get 0. We cool?
Yes.
If I plug in a 0 into that x over there, I got a 0 plus 1, which is 1. Square that, which is 1. Multiply that by -1/2, and it's 1 times a -1/2 is -1/2. What do you want from me? All right. Let me plug in a 2 or a +1 into here. I got 1 plus 1, which is 2. Square that, which is 4. 4 times -1/2 is -2. We cool?
Yes, we are.
I'm going to plug in 2 into there, and I've got 2 plus 1, which is 3. 3 squared, which is 9. 9 divided by 2 is 9/2. I don't know.
Something.
-9/2, which is about 4.5.
9 divided by 2.
4.5. Alright, now I'm going to plug in 3 into there, and I've got 3 plus 1, which is 4, squared, which is 16. 16 divided by 2, which is 8, but it's negative, so it's -8. That was almost synchronized. That was actually pretty
So
cool.
close.
Alright, anyway, let's do this. Alright. If I were to graph this, I would say, okay, at -2, I gotta go down a half. At -1, I'm gonna go to 0. At 0, I'm going to go down a half. At 1, I'm going to go down 2. Oh, and at 2, I'm going to go 4.5. So way down here. And then at 3, I'm going to go down to -9 or -8, which is down here. So here's what my actual graph looks like. All right, so I made it a little fatter than I thought it would. But I mean, you see how it kind of got close.
Kind of. Yes, I do see.
I mean, our guess. We graphed this thing without even plugging in any numbers. We just said,
Which is insanity.
I think this graph is going to be shifted to the left one and then flipped over and made wider. And it was so close to what
There's
we
absolutely
actually...
no order to that.
What do you mean no order? That would make perfect sense based off what we
No,
did.
I mean, it was so random. Like, let's just guess this. Like, no, thank you.
No, but I mean, doesn't that like make you a boss? You're just like, dude, I'm a boss.
Boss isn't a term.
Really?
It's not a term anymore.
It was in the 90s.
It's not a term. It came back for when I was in 7th and 8th grade, but it's no longer a term.
Like do the math like a boss, right?
It's
Like,
no longer a term.
okay, fine.
I'm just keeping you up to date.
All right.
You need to learn the Tumblr lingos. That's what needs to happen.
Oh gosh, you know, I
Because
was
that's
having
what's
this
used
discussion
now.
with my wife yesterday about how dumb reading things on the internet like makes me. When I read it, I'm just like, oh gosh, like I feel like my grammar is
Excuse me, Tumblr.
digressing.
Tumblr can teach you some pretty awesome stuff.
No, it's
No, there's a lot of information on Tumblr.
no.
like,
I'm gonna
cool
be the
stuff.
crickety old man who says, "You kids and your fancy language is it's not."
I feel you.
I'm
For
not
example,
digging it.
Tumblr.
Anyway, yeah, I lose brain cells by reading some of these Facebook posts. I'm just like,
Hey, Facebook post is different. Facebook is stupid. Tumblr is great.
yeah. No, my brother is the worst of them all. I mean, he combines like dumb internet language with dumb pidgin English language.
Oh, that sounds.
And I'm not saying
terrifying.
like dumb pidgin English language is dumb, but I'm saying is like he's like woot woot cat meow, yo
What?
smiley face. I'm like, is that like an actual
Is that a
thing? I don't understand it.
Pigeon kills.
Anyway, and then they're always doing cat sounds.
Meow.
Like, oh gosh, like
Meow constantly.
anyway, all right, none of my business. But anyway, let's go on. All right, tell me, my friends. Let's do another straight up one of your homework for you. Sound good?
Yeah.
Let's do number 5 on page 10. What do you think this parabola looks like?
Wait, where? There's a lot of. Wait, what am I doing?
This is a kind of a dumb question because the answer is right there.
Ha!
I mean, if you look at it, like, what does this parabola do?
Well, the answer's right there.
Well, I mean, look, if I have a parabola, which looks like a regular parabola, and I compare it to my, like, so this is my regular parabola, so it looks something like that. I compare it to this parabola over here, the one that you see. What is the difference?
The difference is it's moved to the side -3.
It's moved -3,
But that means technically in the equation.
and it's also, it's actually, I lied, a regular parabola looks like this.
Liar.
So, if you compare this, it moves to the left 3, I agree. To the left, to the left, to the left. That's it. All right, and then what?
Just this.
And then it's flipped. So that's this one right here. Here's the left 3, here's the flip. Do you guys agree?
Yes.
All right, just because like I think this is actually really kind of an easy problem, why don't we move on to this one? Let's try this one. Obviously the answer is no, but I want you to tell me what that parabola would look like if I were to graph that. Look at this, x minus 3 squared minus 18. What do you do? It's going to go, it's a regular parabola that opens upwards.
It's gonna go to the right 3.
It's going to move it to the right 3 because of this -3 inside. And then what does the -18 do?
God damn.
It's gonna go.
It's going to move it down, down, do your thing 18 times. Yes, exactly.
To the back.
Are we cool with that?
Yes.
Like that parabola, I would say looks something like, so the right 3, down, it's going to look something like that. You guys see what I mean?
Yes.
Yeah, cool. All right. Let's try that one. We're working our way through these things. -3x squared minus 18. What does the -3 do, and what does the -18 do?
Okay.
All right, let's take it piece by piece. The negative in front of the 3, what does that do? So flip it. Yo. The 3, what is that going to do? Size of parabola, what do you mean?
That's gonna make it
No,
wider.
it doesn't flip it down 3,
It's
and
gonna
it doesn't
make
make
it
it wider. It's a number that is bigger than 1. Actually, it's
-3.
bigger, it's smaller than -1.
Yeah. So isn't it gonna make it wider?
No, it's going to make it skinnier.
I thought the small numbers make it bigger.
Okay, wait. All right. The fractions make it bigger.
Angry.
If your number is this, all right. Let's look at a number line.
I thought any number
If
smaller
A-
than 0
If
makes
A
it bigger.
is 0, then you don't have a parabola. You got a straight line,
Uh-huh.
right? If A is a number bigger than 1, all right. If A is positive, then it opens up. You guys agree?
Yes.
Opens up. If A is negative, it opens down. Opens down. Agreed? If A is bigger than negative or bigger than positive 1, then it gets skinny. However, if it's also smaller than negative 1, it still gets skinny.
So only if it's a fraction, it's wider.
If it's fat, or if it's in between this area over here, then it gets fatter.
That's
And if
ridiculous, but okay.
If it's 0, it gets so fat that it's a straight line.
I feel
Your
you.
problem went so flat that it was like, okay, well, I'm straight.
I get it.
You get it?
Well, thank you.
All right. So let's look at this thing right here. The negative 3 is doing what? Well, that flips it upside down and it makes it skinny, by a factor of 3. So we're expecting a skinny parabola. What does the negative 18 do?
It brings it down.
It moves it down 18. I totally agree with you. Let's do this one. Let's talk about it. Let's just talk about it. Ready? Negative 2 times the parentheses x plus 3 squared. And look, this is how beast mode. Do they still use the word beast mode?
No. Don't use the word beast.
All right, fine. You know what? Mr. Dalday is old and crickety and whatever, so I'm going to use whatever lingo I know. This is how beast you can be. Like seriously, your friend is asking you, hey, Brandy, can you graph negative 2 times x plus 3 squared? And then you're like, okay, this is what the graph's going to look like. You don't even use a calculator. You don't make a table. You don't plot points. You just say, boom. Deal with it. The negative 2 does what? It makes it skinny, and the negative does what?
Flip.
We're talking about a flipped, skinny parabola. The plus 3 does what?
Brings it to the left.
It brings it to the left 3, and the reason why it doesn't bring it up 3 is because it's in the parentheses. If it were outside the parentheses, it would move it up or down, but it's inside the parentheses, so it's moving it right or left, and it's positive 3, so we expect it to go right, and we know that when it's moving right or left, it's going to do the opposite of what we expected it to do. So it moved it to the left 3. This graph would look something like this. If I were to graph that, it would look something like that. Skinny, upside down, move to the left 3. You guys agree?
I agree because it was my answer.
That was a good exercise. I feel like you guys really learned some stuff today.
I feel the same.
Look, and we're already on lecture 2, so I'm done. I finished 5 minutes before the half hour early that I was going to promise that I
Now
would
help
finish.
Bree with her trigonometry.
No, I'm going to wait the 5 minutes. I'm going to make sure I ask.
0?
Do you guys need help? Do you folks need help with turning in stuff? Because look, let's go through this.
I'm sure.
I'm giving you a half hour extra of class of your life that you guys were supposed to spend with me. I'm going to let you guys go early, so give me that 5 minutes, all right? I'm looking at the plan here, okay? And the plan says that what week are we in? The 20th, no, we're in this week. The 20th to the 24th. The plan says that for this week, you have quad 1 due today, the last of quad 1, simple graphing 32 and 35. When I looked in this one, I only had 10 assignments submitted. And this was due on the 21st. This was due last week, this past Tuesday,
Yeah. Right? Yeah.
and I only have 10 assignments. I didn't even check to see how many assignments I had here. And I didn't even check to see how many assignments I had here. And the grade checks are due today. Turn in your work on time. I mean, seriously, folks, I lectured on this stuff 2 weeks ago. That means it gives you 2 weeks to finish it. Even though I only tell you, oh, I'm giving you a week to do the assignment, I finished lecturing on this 2 weeks ago. So, are we cool? Like, you guys are gonna turn in your homework. I'm not angry at you. I'm not mean. I'm just letting you know, make sure you turn in your stuff on time. I need it in on time. And here's the thing. My system is this. I'm not gonna accept late homework. That's a jerk move on my part.
I would have been screwed.
I'm not gonna accept late homework, but what I will accept is resubmits. And I'm gonna accept as many resubmits as you
So
want.
wait, excuse me. If I were to turn in an assignment that only has one question done, but it's turned in,
Then I'll give you an F on the assignment,
but I can resubmit.
and you resubmit it, and I'll grade it again, and I'll give you an A if you get an A. If you get a B, then you can resubmit it again.
What if I turn in a
And get-
blank document just so I can resubmit it?
What I would rather you do, no, I'm serious.
I found a loophole.
No, what I would, and you know what, I don't mind, but what I would much rather you do is this. I want you to at least write down on the problems, I don't understand this. I don't understand. This is what I don't.
What if I do it? It was just like a time crunch.
All right, then write down on your homework. Say,
Happy on a busy week.
then write down on your homework. Say, look, Mr. Dalde, I'm really sorry. I know how to do this, but I didn't have time to do it. Can I turn this in and resubmit it later? And then tell me when you're going to plan on resubmitting it. Don't you be like, can I resubmit it later? Dot. Tell me, can I resubmit it in 2 days? Can I resubmit it next week or something like that? You guys got it? Yes, this is a loophole. You can resubmit things as many times as you want. That's what justifies my jerk move of saying I don't even know it's up late homework. Although I don't think it's that jerk of a move when I'm giving you 2 weeks to do the assignment and they're like 3 problems long. They take like 5 minutes. But
I make so many faces. It's not
Just
even
letting you
funny.
anyway, folks, it's 10:29. Done with my archive. Done with my lecture. It's good to see you. Good to see your faces.
You saw none of their faces.
I saw
You
yours.
saw my face. I'm Harry Dayla.
Why does Jennifer record?
Alright.
I don't know.
All right.
Diamond.
I'll talk to you guys later. Class is done. See you on Wednesday next week.
Mr. Dalde, guess what?
We're gonna finish
What?
off quad 3 and then we're gonna
I'm
move on to
Mr.
quad
Dalde.
4.
What?
I got my license yesterday.
You did? Can you drive me places?
Let me know when you're on the road,
Sweet.
and that way I can make sure I'm in a building.
Okay.
Alright.
I'm a very good driver.
I still need to go to your house because I look like I belong there. Pop Tart Austin